Hi, and welcome back to our Chemistry Flipped Classroom, and we're continuing our conversation today about different types of formulas. So yesterday we discussed empirical formulas, those simple whole number ratio formulas that come from empirical data or from lab data. So this is just our quick reminder that our empirical formula is the lowest whole number ratio of elements in a compound, and that comes from empirical data. And we might remember that ionic compounds are always empirical formulas, but not all formulas are empirical. Not all formulas are the lowest whole number ratios. Our molecular formulas are going to show the actual number of atoms of each element that are present in a compound. Now, these molecular formulas are always going to be a whole number multiple of the empirical formulas. So they're always related. And they can be the same. So sometimes the empirical formula and the molecular formula are going to be the same. In other words, that multiple is 1. So water is a perfect example. H2O, that is the simplest whole number ratio. It means that there's 2 atoms of hydrogen and 1 atom of oxygen. They can't be simplified down and still be whole numbers. That is both the empirical and the molecular formula for water. Same thing with carbon dioxide. Can't be simplified down anymore. 1 carbon, 2 oxygens. That is both the empirical and the molecular formula. But a lot of the time, they're not. And so examples of that would be things like hydrogen peroxide. That's H2O2. That can be simplified down to a 1-to-1 ratio. The empirical formula for hydrogen peroxide is HO, but its molecular formula is H2O2 because in the molecule there are 2 atoms of hydrogen for every 2 atoms of oxygen. Glucose is another good example, C6H12O6. Its empirical formula, reduced down to the smallest whole number ratio, is CH2O. That's the empirical formula. That's what we would get from laboratory data. But we know that the actual molecule contains 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. So, knowing that, having learned how to find empirical formulas, how can we get from an empirical formula to a molecular formula? Well, it's pretty simple, and we just need one more piece of information in order to find our molecular formulas from our empirical formulas. So the first step in converting an empirical formula to a molecular formula is going to be to find the empirical formula. If it's already given, you're one step ahead. Your next step is going to be to determine the formula mass of the empirical formula, and then to divide that molar mass that you're given. So that's the piece of information you have to go from an empirical formula to a molecular formula, is the molar mass. So if we know the molar mass of the compound, we can divide it by the empirical mass of the empirical formula, and that's going to give us an integer. It's going to give us a whole number. And we'll then multiply the subscripts of the empirical formula by that integer to get the molecular formula. So we just need one more piece of information to go from empirical to molecular, and that's molar mass. And we can't go from empirical to molecular without molar mass. So let's take a look at an example. Here we have adipic acid, C3H5O2. And we're asked to go from empirical formula to molecular formula. So the first step was to find empirical formula, and that's already given to us right here, C3H5O2. So step 1 is done, C3H5O2. If we were given percent composition, we would have to do the steps we did yesterday to find the empirical formula, and then we could move on. So for step 2, we have to find the empirical mass. So we're going to do 3 times the mass of carbon, 12.01, plus 5 times the mass of hydrogen, which is 1.01, plus 2 times the mass of oxygen, which is 16.00, and we're going to get 73.08. So step 2 is done. Now step 3 is to divide the molar mass, which we were given 146, by the empirical mass, which we just found, which is 73.08. And that's going to give us a number that is slightly less than 2, but this should always give us an integer, so we're going to say, well, that's about 2. And now we're going to multiply the subscripts by that integer. So we started with C3H5O2, and we're going to multiply each of those subscripts by 2, because that's the number we just got here. And we're going to get C6H10O4. And so this is the molecular formula for adipic acid. Okay, let's look at one more quick example. So yesterday in our empirical formulas, we found the empirical formula of ethylene glycol. It's CH3O. And now you're being given one more piece of information. Its molar mass is 62.1 grams per mole. So we're going to repeat those same steps. So first we're going to find the empirical formula, so CH3O. And then we're going to find its empirical mass, so the mass of carbon, plus 3 times the mass of hydrogen, plus the mass of oxygen. Oops, lost a decimal place there. So we have 29.04 grams per mole. And then we need to divide the, did I do that correctly? Yes, okay. We're going to be given the molar mass, and we were given the molar mass as 62.1 grams per mole. And so we have 62.1 divided by 29.04. We're going to say that's about 3. About 2. Can't math. Okay. And so we're going to take CH3O and we're going to multiply it by 2. And we'll wind up with C2H6O2. And that is the molecular formula for ethylene glycol. Okay, I look forward to hearing your questions and seeing you in class.